Hello students, in this online course we are going to learn about database management system. I am Aniruddha Biswas with you for the next upcoming online classes on database management system. Today we are going to start with chapter 1, Introduction. What are the topics that we are going to cover? Database system application, purpose of database systems, view of data, database languages, design, the engine, the architecture, users and administrator, and finally the history of the database system. Starting with the concept of database systems. Database system is a collection of data. Definitely they are correlated or interrelated collection of data. The set of programs to access the data, that is also very important. An environment that is both convenient and efficient to use. Database systems are used to manage collection of data. Those are highly valuable, relatively large, and accessed by multiple users and applications, often at the same time. A modern database system is a complex software system whose task is to manage a large and complex collection of data. So it is a collection of tools that helps us to store the data which are closely in nature and then storing them and as and when required to retrieve them using some query language. So this is what the database management system is. Now briefly we'll discuss about different applications of database management system. In different enterprise like sales related, accounting related, human resource related, we use database management system. Not only that, in the manufacturing field like inventory, order supply chain, production, everywhere we use database management system. Not only that, the banking and finance also require huge database. For example, the customer information, accounts, loans, banking transactions, credit card transactions, etc. And among these, also the university database is also very important, like the registration and grades of different students we need to take care of. Apart from these, the airline reservation system, schedules, like telecommunication system, records of calls, texts, web services, tracking of order, and customized recommendations, online advertisements, all require databases. Not only that, in navigation system also. Now we'll talk about the purpose of database systems. Data redundancy and inconsistency. Basically in file system, this is a anomaly that inherently comes. Data is stored in multiple file formats that results in duplication of information amongst various files, and definitely there is lot of difficulty we face while we access data from different file which are different in nature. The isolation of data is also very difficult. It means multiple files and formats are there for storing different types of data, or even the similar data are stored in different file formats. So in this regard, there is a huge integrity problem. Integrity constraints become buried. Like for example, integrity constraint like account balance should be greater than 0, which cannot be imposed in file management system. And very hard to new or add new constraints, and changing the existing one is also very difficult. Failures may leave database in an inconsistent state with partial updates carried out. Let's say, for example, transfer of funds from one account to another should either complete or not happen at all. Then, due to concurrent access by multiple users, it reduces the performance. The uncontrolled concurrent access can lead to inconsistencies as well. There is security problem, hard to provide user access to some but not all data. Okay. Now we talk about different problems: the atomicity problem, concurrent access problem, security problem, inconsistency problem. All these problems, one solution is a database management system. So DBMS offers one step solution of all these problems compared to file management system. Now let's discuss about the university database. Okay. In university we have student, we have instructor, we have different classes, courses assigned to those instructors. So all this information must be maintained. So that is what we do in university database. Now coming to reviewing of data. A database system is a collection of interrelated data that we already come to know when we discuss about the database management system. A major purpose of database system is to provide users with an abstract view of the data, like the data model in one side and another is data abstraction. Model means its representation of data, the relationship between them, the semantics and consistency constraints, all this. And hide the complexity of the data structures that is being taken care of with the help of the data abstraction. And there are different granularity levels of data abstraction, so we will discuss in details of that as well later. Now coming to the very important concept of data models. So data model is from earlier days, since 1960 to 1970. At this time there were some old or legacy data models being used, which are known as network model and hierarchical model. But that was a very early stage, and after that, in year 1970 to 1980, the relational model came into picture side by side. The entity relationship model, then comes object oriented and object relational model, and also there is something called semi-structured data model, that is XML, that also came into picture later. Now what these data models comprises of: there is data, there is relationship between data, data semantics is there, and the constraints are also there. So this is the overall discussion on data model. Now we talk about data model, and after the legacy system was over in 1970, that is the network model and later the hierarchical model. So these two models age was outdated, so the new model came into picture, that is called relational model, and the inventor of the relational model was none but Ted Cord, and in 1981 he was awarded the Turing Award. So here what exactly happens: the data is stored in a tabular form, right? uh, One is the column, this is the columns, and these are the records or rows, fine. So every row is basically signifying a different instructor. So the first instructor is Einstein, his department is physics. So every column, corresponding to every column, there are a set of data that is called domain. So this is the department name domain. This is also known as field. So this is a field, and rows are also termed as tuple. Okay, so these are called as tuple. So every tuple contains 4 fields for this particular instructor table. So this is how the relational data model is constructed, and some few more examples of like instructor table as well as department table. The construction is same, but the column names are different. These are the different column names in different tables. Now coming to the abstraction, there are 3 different levels of abstraction. Physical level, that basically physically contains the records, the raw data. Logical level means it contains the data structure, what type of data it should contain. That thing is depicted in the logical level. And the view level is the application program that hides the details of data types as well as the actual data. It gives the leverage to view the information, maybe information of the salary of employees. Someone may be interested with the address where the employees are. So different views are there. So this is the application program that hides the details of data types. So this is view level. So abstractions are there in every level. Coming to the next thing, that is viewing of data. So this is the architecture of the database management system architecture, you can say. The top level or the outermost level, that is the application level, you can say. Application level. And here the logic level is basically a gateway that provides support to the application level to retrieve information from the physical level. So this is basically concept level, concept layer, and this is the internal layer or physical layer, or we can say data layer. So this is the data layer. So this is the 3-tier architecture of database management system. Now we should also highlight on something called the schema. There are 2 different types of schema. Logical schema that basically deals with the logical structure, overall logical structure of the database, and physical schema is the overall physical structure of the database. Apart from this, there is something called instance. Instance means actual content of the database at a particular point in time, point of time. Let's say the value of a variable, that is an instance, right? So this thing you can better understand if we talk in a programmatic way, like value of a variable, that is the instance. Okay. Now physical data independence and logical data independence, these 2 things we should understand. Physical data independence means if we change anything in the physical level, then that will not hamper the logical level of or layer. So that is called physical data independence. Whereas if we make any change in the logical layer, so it will not hamper the other layers. So that is called logical data independence. And so we understand that there are 2 types of data independence. One is physical data independence and another is logical data independence. Now, what is DDL? Data definition language. In the study of SQL, we will come to know or come across about this DDL, DML, DCL and ECL concepts. But here in the introductory part, we will give an overview of all the chapters that we will cover, the upcoming online classes. So here DDL means data definition language. Let's say, for example, we talk about relation. Relation means table. So table can be constructed, but how? So the logical structure of the table, where it defines what is the data type of every field and what will be the size of that, and is there any primary key in that particular table or not, or any constraint is defined or not, integrity constraint, domain constraint, etc. So all these things must be maintained in the logical layer section. Okay, so that is done in the DDL statement. So that is how the DDL is creating a table is called a DDL statement, as well as creating something else like other objects like views, creating procedure, creating index, all comes under the data definition. Okay. Now there is something called concept of data dictionary. It is a collection of metadata. That means actual record is stored in table, but the structure is stored in the DDL statements, using the DDL statements. So the template of the table is stored somewhere. So that place is known as the data dictionary. Okay. So in the data dictionary, we store the uh, metadata information, where the database schema is stored, integrity constraint is stored, primary key, authorization, etc. Everything is stored there. Now coming to the SQL query language, though we will discuss in details about this, but here in short we will come to know or discuss about different queries of SQL. Let's say one DML statement or declarative DML statement, that is selecting all the instructor names from the Department of Computer Science. So this is how we can get the instructions from here. And SQL is not a Turing machine equivalent language to be able to compute complex functions. SQL is usually embedded in some higher level language as well. Now there are some more complex thing that we need to understand in a nutshell here, not in details, but application programs generally access databases through one of the language extension to allow embedded SQL. Let's say, for example, the Java, Python, JavaScript, etc. languages helps us to embed the SQL to access the database layers. Okay. Apart from that, there are some connection oriented logical programming like ODBC and JDBC programming are there, which helps us to access the database via some logical programming language. Okay. Now coming to the concept of database data manipulation language. And there are two types of data manipulation languages: procedural and there is declarative. The procedural DML require a user to specify what data are needed and how to get those data, and declarative DML require a user to specify what data are needed without specifying how to get those data, right? So one is specifying and another is without specifying. Both retrieves the data. Procedural means we have to specify the required data, how to retrieve it, and declarative means we don't they require a user to specify what data are needed without specifying how to get those data, right? So this is the difference between declarative and procedural. Now coming to the query language, these are the different query language, and XML is semi-structured query language that we already discussed. Now non-procedural query languages such as SQL are not as powerful as a universal Turing machine, right? So SQL does not support actions such as input from users, output to display, or communication over the network. So I already discussed about the application programs where Java, Python, PHP or JavaScript, they support the embedding of SQL. So that is very important. Now we'll talk about the database design. The logical design and the physical design are most important here to understand. And then that comes to the concept of database engine. A database system is partitioned into modules that deal with each of the responsibilities of the overall system. And the functional components of a database system can be divided into the storage manager, query processor component, the transaction management component, etc. So coming to the storage manager part, where we store the data. Definitely we would have some storage media that should be non-volatile, means permanent storage media like hard disk and all. And we need to interact with the operating system file manager as well. So efficiently storing, retrieving, updating of data is required by the storage manager. And what are the components are there in storage manager, like authorization and integrity manager, transaction manager, file manager, buffer manager, etc. Now there are some physical system implementation, that is a data file store the database itself. Next comes data dictionary, what stores the metadata information. The indices can provide fast access to the data items, that is also very important in case of database. Indices provides pointers to those data items that hold a particular value, right? Now coming to the next concept of query processing. Query processing means DDL interpreter, DML interpreter, etc. there, because all the queries are not only DDL or DML. So both kinds of processors are there in SQL engine, and we'll come to know how the query evaluation engine works. There are three different steps. Number one is parsing and translation. So this thing is done in this portion. Query is fed into the parser and translator. So after parsing, it in the backup it stores the relational algebra expression, and after the relational algebra expression we get it fed to the optimizer. Optimizer actually takes help of the statistics about the data. Based on that, it optimizes the query and it creates an execution plan. And according to the execution plan, that evaluation engine takes some data from the database, process it, and whatever the intended output that it generates, and that is called the query output. Okay, this is how the query processing is done. Now in short, we'll discuss about transaction management as well. So what transaction management says, transaction is a collection of operations that are related and performs a unit of task at the end. So that is called a transaction. And there are different transaction management components like that ensures the database remains in a consistent state. So consistency is the key aspect of transaction. So whatever happens, even there is power failure, operating system crashes, transaction fails, but the database must remain consistent, right? And there is something called concurrency control manager. So parallel transactions could cause deadlock or some unwanted phenomena. So concurrency control manager basically helps to control those unwanted situations. Coming again to the database architecture, basically there are few different types of database architecture, like centralized database, client server database, parallel database, and distributed databases as well. So if we talk about the centralized and shared memory database, here we can look into this. This is the disk storage, where from the data is coming to the storage manager. and according to the transaction manager or authorization or integrity manager, file manager, and buffer manager. All these information are fed in a query processor, where the query processor basically execute the query and produce the intended output, right? Now coming to the applications of database management system, there are two types of architecture that we have already know or discussed about, the two-tier architecture and three-tier architecture. Basically, the difference is that the database layer and logic layer is merged in two-tier architecture, whereas the three-tier architecture has three different layers: the view layer, the internal layer, and the physical layer. Now we'll discuss about the very important aspect of database users. Different types of users are there. Naive users who only does some select operations or view the data. There are some users which are known as application programmers. They write some codes for enhancing some functionality of programs or application programs. There are something called sophisticated users, analysts, and they use the query tools. And last but not the least, there is something called administrator. Okay, database administrator. They basically administer the tools, process different activities. So the roles of the database administrator is very important. They takes care of the health of the entire database system. They look after the backing up process of database if storage is full. They monitor the upgrading of disk space and jobs running on the database, that is also being monitored by DBA. Routine maintenance is done, and also granting the access to the different users is also done by the database administrator. Now last but not the least, we will discuss about the history of database system. The starting of early 60s, that means starting from 1950 to 1960, the data processing using magnetic tapes for storage. Tapes provided only sequential access, the punch cards for input, and after that in 1960s and 70s, hard disk allowed direct access to data. The network and hierarchical data models in widespread use at that time. IBM Research begins System R prototype. UC Berkeley begins Ingress prototype. Oracle releases first commercial relational database. That was the beginning of Oracle. And transaction processing also started at that time. In 1980s, research relational prototypes evolve into commercial system, and SQL becomes industrial standard from 1980s. So in 1990s, large decision support and data mining applications came into picture, and also emergence of web applications at that particular time. After that, 2000, big data storage system came into picture, the Amazon, then NoSQL systems came, the MapReduce and friends, that technologies came into picture. Then 2010, SQL Reloaded, the front end and the MapReduced systems came into picture. And finally in 2020, at the era of AI and robotics, the container database, cloud database came into picture. So this is the history of the database management system. So in chapter 1, we conclude with this. So these are the things that we discussed. Thank you. Keep watching the next online classes of database management system.